Analysis of the parabola. In this lesson, we're going to learn about some terminology related to quadratic relations and how we can identify those from given diagrams. So the first thing that you want to learn about is the axis of symmetry. So the axis of symmetry is an equation of a line that splits the parabola directly in half. So unlike the human face, the parabola has a truly symmetrical shape. So what that means is that it's the same on one side of the parabola as it is on the other. So if one arm of the parabola is reflected in the mirror line, or the axis of symmetry, the other arm is created. And because the axis of symmetry is a vertical line, and we talked about how we can identify the equation of vertical lines when we looked at linear relations, it has a slope that is undefined. And this equation is written as x equals something, where that something is whatever number it passes through on the x-axis. So if I was to draw a random parabola, let's say it's about right here, and I was to draw in my axis of symmetry, so this, I'll do it in a different color actually. So this is my axis of symmetry right here. It has it passes through, we have to figure out what the equation of this line is, right? So it passes through this axis of symmetry is when every x value is 2. So every x value on this line is a 2. So the x-intercept is 2. So that helps us as well. So the axis of symmetry for this parabola is x equals 2, because that's where it crosses through. The next equation or next definition that you need to know is x-intercepts. Now, x-intercepts of the parabola are also called the zeros. So you might see those words being used interchangeably. So there could be 0 zeros, 1 0, or 2 zeros. So what does that mean? Well, what does that look like graphically? If it has 0 zeros or no zeros, then that means your parabola never touches this x-axis. So it could open up, right, in the top half, or it could open down, but it never ever touches that x-axis. So the x-intercepts and the zeros are interchangeable. If we have 1 0, that means the vertex of the parabola, and that's one of the definitions we're going to take a look at later on. The vertex of the parabola, it lies right on the x-axis. So this point right here is your 0, which is also the vertex. We're going to take a look at that, again, that definition a little bit later. And what happens if we have 2 zeros? What does that mean? Well, that means it intersects or it crosses the x-axis in 2 spots. So again, if I was just to draw a parabola, you can see that I have an x-intercept here and I have an x-intercept there. So it has 2 zeros, 2 points where this graph crosses the x-axis. So that's what the x-intercepts are, which is also called zeros when we are referring to them as in quadratic relations. The next definition that you need to know is the y-intercept. The y-intercept is the same as what it would have been when we had a linear relation. So it's where it crosses that y-axis. So the parabola crosses the y-axis at the x-intercept. So if I was to draw a parabola, maybe we'll go like this. This is my y-intercept. And I would have a y-intercept at the coordinate 0, 4. So it's important to know that. So the y-intercept always is where it crosses that y-axis, or the x is 0. Some more definitions. The reflected point. So any point on one arm may be reflected in the axis of symmetry to create a reflected point. And we call that reflected point, we can call it an R on the other arm. So as we mentioned before, and when we looked at the axis of symmetry, so every parabola has an axis of symmetry. So here is my axis of symmetry, right? So this is my axis of symmetry, or my mirror line. So this is the line where if I was to fold this parabola directly in half, both sides of my equation would be exactly the same. And if I was to have a point, and I didn't draw my parabola very well, I'm going to redraw my parabola for you, so it's a little bit more accurate. That's better. So here again, so here is my parabola, here is my axis of symmetry. If I have a random point, so let's say it's this point right here, I notice that this point is 2 units away from my line of symmetry. So that means directly opposite of that would be the other point. So the reflected point would be 2 units from the other side. So these 2 points would be reflected points right here. Because they are equal distance away from the axis of symmetry. And that's going to be very helpful when we are sketching our parabolas without having to do a table of values. The next thing that we have to look at is called the direction of opening. We talked about that a little bit in our previous lesson, where we explored what happens when we have a negative sign in front of our x squared. So the sign in front of the x squared, so whether it's a positive value or a negative value, determines the direction of opening. It may also be referred to as a reflection in the x-axis in terms of if it's negative. So the parabola opens up when the sign is positive. So an example might be y equals x squared. or y equals 3x squared. Okay, so this would be, if it opens up, that means our value in front of the x squared is positive. The parabola opens down when the sign is negative. And again, we looked at that in our previous lesson. So this could be y equals negative x squared, it could be y equals negative 2x squared, and so on. So it just means from a random point, our parabola opens down. Okay. And because of our direction of opening, it'll determine a difference between our maximum or a minimum, or the vertex. It helps us figure out what that is. So depending on the direction of opening, will determine whether our vertex is called either a maximum or a minimum value. So the parabola changes direction at the point called the vertex. So if we were to look at these two parabolas right here, if I'm looking from left to right, it starts to go down until it reaches this bottom point, and then it goes back up again. For this one, it goes up until it reaches a certain point, and then it goes back down again. So where it changes direction is called that vertex. So that point right in the middle, where it crosses through the axis of symmetry, is where the vertex is. So the vertex can be the top of a mountain or a maximum point, or it can be at the bottom of the valley or a minimum point. And the axis of symmetry always passes through that vertex. So again, let's take a look at quickly draw some sketches. It doesn't matter where your parabola is. So right here is my vertex. And because it is the lowest point, so my graph can never go lower, then it becomes a minimum value. So this is the lowest point that my parabola reaches. So that's a minimum value. And our vertex is always a coordinate. So the coordinate of this is 1 and 2. 1 and negative 2. So I'm going over 1 and down 2. So 1 and negative 2. If my parabola opens down, so maybe it looks like this. Okay, so I have my vertex right there. This is my vertex. I can identify the coordinate of my vertex. So this is 0 and 1, 2, 3, 4. I know that my axis of symmetry will pass through this. So this is my axis of symmetry. I can draw it on this diagram as well. So this is my axis of symmetry. But this time, this vertex is the highest point that this reaches. So it never goes higher than this point. So this is the maximum point that my the maximum value or the optimum value are also some different things that you might hear. This might be called the optimal value when we're talking about minimum or maximum value as well. Okay. So let's take all of that information and apply it to some examples. So we're going to take a look at these parabolas and we're going to determine the axis of symmetry. We're going to state the zeros or the x-intercepts. We're going to figure out where the y-intercept is. We're going to identify the direction of opening and the vertex. So I'm going to first start by figuring out, well, I can easily figure out where the y-intercept is. So here's my y-intercept right there. So that's my y-intercept. So it has a point of 0 and -3. The next easiest one to probably find is our x-intercepts. So it looks like it's pretty close to being at -1 and 5. So these are my zeros, or my x-intercepts. So I have one at -1 and 0, and I have another at 5 and 0. And now we want to figure out, does this open up or does it open down? And the way that I like to think about it is if it makes a U shape, it opens up. And because it opens up, it's going to have a minimum value. And the minimum value is going to be at that vertex. So where is my vertex? My vertex is right here. And it has a vertex at the point 2 and -5. And the last thing that I need to do is to draw my axis of symmetry. So my axis of symmetry goes straight through the vertex. And this is a vertical line that has the equation of x equals 2, because that's where it crosses the x-axis. Let's do a few more examples. Here's my other parabola. So let's start. It probably is easier, again, to say that it's easier to find the y-intercept first. So there it is right there. There's my y-intercept. So it has a point of 0 and 2. Now I want to figure out what the x-intercepts are. Well, it never touches the x-axis. So there are no zeros. Okay, because it doesn't touch the x-axis. So you'll always have a y-intercept, but you might not have x-intercepts. Now we'll state the direction of opening. It creates a U shape, so it opens up. And because it opens up, we have a minimum value. And we have a minimum value at our vertex. So there's my vertex. And my vertex has a coordinate of -1, 1. And my axis of symmetry goes directly through that vertex, and it crosses the x-axis at -1. So the equation of my axis of symmetry is x equals -1. Let's do one more example. I'm going to start by identifying my y-intercept. So it crosses the y-axis right here at the origin. So this is my y-intercept. So my y-intercept is at 0, 0. Where are my zeros, or my x-intercepts? Well, here's an x-intercept. And here is an x-intercept. So I have two x-intercepts. So I have one at 0, 0, which is exactly the same as my y-intercept, and I have another at 8 and 0. So those are the coordinates of those 2 points. Looking at my direction of opening, my direction of opening, it opens down. So it creates sort of an N shape. So it opens down, down ends with the letter N, and this sort of looks like an N. And because it opens down, it has a maximum value at my vertex. So there's my vertex right there. And my vertex has a coordinate of 4 and 8. And my axis of symmetry goes straight through. This is my axis of symmetry. Straight through the vertex, and it crosses the x-axis at 4, so it has an equation of x equals 4. If you have any questions about this lesson, please reach out to me, send me an email, sign up for a virtual help session, and I will see you in the next lesson.